A single delayed cargo ship in a critical strait can trigger a multi-billion-dollar cascade of global shortages within 48 hours. For decades, global supply chains have operated in a state of fragile reactivity, plagued by chronic blind spots and unpredictable logistics disruption. Companies have historically relied on fragmented data, manual updates, and siloed communication to move goods across the planet. This outdated approach creates a massive visibility gap, leaving business leaders blind to incoming storms, both literal and economic, until the damage is already done. The cost of this uncertainty is measured not just in delayed shipments, but in lost revenue, wasted inventory, and shattered customer trust. The era of hoping for the best in global logistics is rapidly coming to an end. Artificial intelligence is fundamentally changing this landscape, acting as a powerful central nervous system for global commerce. By integrating vast, disparate datasets, AI systems are replacing hope with mathematical certainty. The technology moves operations beyond simple tracking, creating a unified, real-time picture of every moving part across continents and oceans to ensure absolute supply chain visibility. At the core of this transformation is a specific branch of artificial intelligence known as predictive analytics. This technology relies heavily on a neural network, which is a computing architecture inspired by the human brain, designed to recognize complex patterns within massive datasets. Instead of just recording where a shipment is right now, these neural networks analyze historical shipping logs, current weather patterns, geopolitical events, and port congestion metrics. They process millions of variables simultaneously to calculate exactly what will happen next. By ingesting this continuous stream of global information, the algorithms identify hidden correlations that human analysts could never spot. If a storm is brewing in the South China Sea, the system does not just flag the weather event. It instantly calculates the probability of port closures, predicts the subsequent backlog, and identifies which specific purchase orders will be delayed. This capability allows businesses to anticipate potential issues days or even weeks before they escalate into critical failures. The foundation of this predictive power relies on the physical world feeding data into the digital one. This is achieved through IoT sensors, or Internet of Things devices, physically attached to shipping containers, pallets, and delivery vehicles. These small, rugged devices transmit continuous real-time data regarding location, temperature, humidity, and vibration. As a container moves from a factory floor to a cargo ship, the sensors guarantee absolute AI visibility at every step of the journey. When this real-time sensor data meets predictive algorithms, the results are transformative. A logistics manager no longer has to guess if a sensitive shipment of pharmaceuticals remained at the correct temperature during transit. The system actively monitors the cooling units, predicts potential equipment failures based on subtle temperature fluctuations, and automatically alerts maintenance teams before the cargo is compromised. It is a seamless fusion of physical tracking and digital foresight. Leading technology providers are already proving the immense value of this integrated approach. A prime example is IBM Supply Chain Intelligence, a suite that leverages advanced AI platforms to offer unprecedented insights into logistics networks. By deploying these tools, enterprises can visualize their entire supply chain on a single dashboard, with predictive alerts highlighting specific vulnerabilities in real time. The platform acts as an intelligent control tower, transforming reactive operations into proactive strategic advantages. The shift driven by platforms like these fundamentally changes how goods move worldwide. When an anomaly is detected, the AI does not just raise an alarm. It instantly models dozens of alternative routes, calculates the financial impact of each option, and recommends the most cost-effective solution. If a primary supplier faces a sudden material shortage, the system automatically identifies secondary suppliers with available inventory and reroutes shipments to keep production lines moving. To make these deeply complex systems accessible to human operators, the industry is increasingly integrating generative AI. This refers to artificial intelligence capable of creating new content, text, or data based on the patterns it has learned. Behind this sits a large language model, or LLM, which is an advanced AI system trained on vast amounts of text data, allowing it to understand and generate human-like language. Instead of navigating complex databases, supply chain executives can simply ask their system questions in plain English to understand network vulnerabilities. Interacting with these highly advanced conversational interfaces introduces a new critical skill known as prompt engineering. This is the practice of carefully designing and refining the text instructions given to an AI to produce the most accurate and useful output. A supply chain director might engineer a prompt asking the LLM to summarize the downstream impact of a sudden labor strike at a major European port. The AI instantly synthesizes the predictive analytics, the IoT sensor data, and the geopolitical context to deliver a clear, actionable executive brief. The integration of these conversational models with predictive engines is accelerating a massive operational shift. The traditional friction between data analysts and logistics managers dissolves rapidly. Decision-making that used to require days of cross-departmental meetings and spreadsheet analysis now happens in minutes. This speed is not merely a convenience, it is a critical survival mechanism in an era where market dynamics can flip overnight. The financial implications of this proactive resilience are staggering. By avoiding expedited shipping costs, reducing inventory stockouts, and minimizing spoilage, companies are reclaiming billions of dollars previously lost to inefficiency, with some networks recovering up to 14.5% of their annual logistics budget. Furthermore, this dynamic routing capability allows businesses to operate with much leaner inventories. They no longer need to stockpile excess goods in expensive warehouses just to buffer against unpredictable logistics disruption. Looking ahead, the trajectory of this technology points toward fully autonomous supply chains. We are moving beyond systems that simply recommend actions to systems that execute them independently based on predefined risk tolerances. Future iterations of these predictive networks will automatically negotiate freight rates, book cargo space, and adjust purchase orders in real time without human intervention. The AI will continuously optimize the flow of global commerce, adjusting to micro-fluctuations in demand and supply with superhuman speed. This evolution will fundamentally redefine the role of the human worker in logistics. Instead of acting as dispatchers frantically putting out fires, supply chain professionals will become strategic architects. They will focus on designing more resilient network topologies, building stronger supplier relationships, and setting the overarching parameters within which the AI operates. The algorithms will handle the tactical execution, while human intelligence guides the long-term vision. Beyond corporate profitability, the rise of AI-driven supply chains carries profound implications for global sustainability. The optimization of shipping routes does not just save money. It drastically reduces fuel consumption and greenhouse gas emissions. By accurately predicting demand, companies manufacture and transport fewer unnecessary goods, cutting down on industrial waste. Predictive analytics is quietly becoming one of the most powerful tools available for reducing the carbon footprint of global trade. According to recent industry analysis, the adoption of these intelligent networks is no longer a competitive advantage but a baseline requirement for survival. Companies that cling to manual tracking and fragmented systems will simply be unable to compete with the speed, agility, and cost efficiency of AI-powered competitors. The gap between the technologically empowered and the technologically stagnant is widening rapidly, creating a new dividing line in global commerce. The chaotic, opaque supply chains of the past are being systematically dismantled and rebuilt through the lens of artificial intelligence. By fusing real-time physical data with advanced predictive algorithms, businesses are finally achieving total visibility over their global operations. This is not just an upgrade to shipping logistics. It is a fundamental rewiring of the global economy, ensuring that the critical arteries of international trade remain open, resilient, and relentlessly efficient.